Well, greetings from Washington, friends in Korea, and thank you for the amazing opportunity and honor to be part of your conference. If I could just say one brief word of introduction, just how much the US ROK Alliance means to me. My father served there around 1960, and I've been to Korea many times, and I am a huge admirer of the Korean people and of the Korean armed forces. And in this turbulent time, if you'll forgive me making a little bit of a play on words in English, with so much about the world unsettled, it's nice to know that the rock is a rock, that the Republic of Korea is always solid and dependable, and that the Korean armed forces are so strong and capable. So thank you. I've been asked to speak about technological change and its implications for military innovation and for future warfare. And this is a topic I've studied going back to my days in graduate school in engineering, and have continued to attempt to stay current on technological trends in military matters ever since, and written several books regarding this general topic. And I would begin with the broad observation that quite often military innovation and technological change, while always very important in our world, and the Korean economy proves this with all of the innovations that you've pushed both in commercial and in military matters. Even so, we sometimes exaggerate what is possible with the next generation of technology. And it's important to innovate. It's important to be ambitious. It's important to try to do new things, but it's also crucial to remember what may not be changing so fast. And let me give just a couple of examples. I remember very well the debate in the 1990s about the so-called revolution in military affairs, and I wrote a book about that. And in the US military, and in the US Army in particular, one of the ideas that became very popular in the late 1990s was the idea that led to the future combat system, and the notion that not only computers, but all areas of technology were poised for such rapid breakthroughs that we could essentially reinvent our ground forces over the next 1 to 2 decades, and basically discard most of what we had at that point, including Abrams tanks and Bradley fighting vehicles and so on. And the Army, as you undoubtedly, some of you at least will remember, given your close associations with the US Army, had very ambitious goals for vehicles that by the year 2010 would be able to move at 200 kilometers per hour on terrain, and that would only have to weigh 20 tons instead of 70 tons of the Abrams tank, because they would be so nimble and so well equipped with sensor technology that they would see threats coming before the threats could reach the vehicle, and therefore could send out interceptors or jam the sensor on the incoming weapon, or otherwise protect themselves through a non-kinetic means, or through essentially an offensive kind of defense rather than armor. And the Army developed a wide suite of plans based on this basic vehicle concept. And some good things happened out of that program, don't get me wrong, but the program was essentially a failure and was declared as such by roughly the year 2010, the same year when, in theory, we were going to have vehicles that could go 200 kilometers per hour on land, which, of course, should have been recognized to be nonsense from the start, because there were no technologies that were anywhere near fruition that could do that. And we heard other ideas back in that debate. For example, the oceans will become transparent, or we'll have ships that can go 80 or 100 knots, or we'll be able to reduce the cost of launch into space by 90%. And none of these predictions were true, or were proven true either. There have been areas of important technology growth and progress, but not anywhere near what was projected. Okay, so that's the historical setting. Let me now come up to the year 2024 and think about not just where we've been, but where we may be headed. And what I tried to do as we got to the year 2020, I did another study similar to the one that I had done 20 years earlier. And I tried to look at all different types of areas of military technology and ask myself, where are the current systems or current efforts poised for big breakthroughs? And I tried to categorize. So I have a section on sensor technology, a section on computers and digital matters, a section on vehicles and propulsion, and then a section that's sort of miscellaneous that includes non-lethal weapons and radio frequency weapons and particle beams and things like that. And for each of these broad categories, I broke down one by one and tried to get about 8 or 10 subcategories. And then go back to my physics and engineering and estimate where I thought progress was happening relatively quickly, where it was more moderate, and where it could be revolutionary in its implications for the battlefield. And I don't want to paint with too broad of a brush, but what I discovered, and what I would argue today, is that sensor technology in most areas of sensor technology is moving relatively moderately, not in a revolutionary way. We are not going to be able to make the oceans transparent. We are not going to be able to figure out where most North Korean soldiers might be if they're dug in and underground. We are not going to be able to see inside of most buildings unless we're right next to the building and have some kind of a high energy particle beam, or maybe a sonar system, maybe an active sonar system, but we're going to have to be very close to the building to be able to see inside. We're not going to be able to see through forest very well, unless, again, we're very close and we have high energy sensor equipment. And so most of the challenges of the battlefield are going to remain difficult when we're talking about complex terrain like on the Korean Peninsula. And I'll come to Ukraine in a second, because I realize that this is not categorically true for everything. There are areas of sensor technology where we could expect substantial progress, but in broad terms, I don't think we're seeing radical change, and I don't think we will see radical change over the next decade or so. By the way, for each of these areas, I did my own assessment, and then I went to some of our weapons laboratories. For example, Johns Hopkins University Applied Physics Laboratory, or Los Alamos National Laboratory, Lawrence Livermore National Laboratory, Sandia National Laboratory. And I asked some of my friends who worked there and who were full-time PhD physicists and engineers to comment on my own assessment and to tell me where they think I might be wrong. And so I did factor in those kinds of expert views. I did not rely exclusively on the master's degree that I received in engineering in 1988. I tried to push beyond and include a lot of other views. And so I think that I've got a fairly well constructed set of predictions. So in sensor technology, progress is generally slow or moderate. In vehicle technology, same thing. So the internal combustion engine is not changing that fast. We're working very hard to have battery-powered vehicles, but they don't really go any faster than internal combustion engines, and they're not really any particular advantageous capability vis-a-vis an internal combustion engine. They're better for the environment, but they're not better for the battlefield. And ship technology is limited by the same physics that continue to keep ships typically operating in the realm of 25 to 30 mile per hour speeds, because the hydrodynamics of moving through water are such that, at least for a big ship with a traditional engine, it's very hard to go any faster than that without encountering huge resistance. And so the striking thing to me about ship technology, and this may be less relevant for the Korean fight, but it could be relevant in some specific niches of a fight in Korea. The interesting thing is that we are still operating ships with roughly the same top speed that we had in World War I. Big military transport ships and big warships are not that much faster today than they were in the Battle of Jutland. It's amazing, but we're sort of still around that 30 mile per hour, 30 knot range. That's not true, again, for everything. There are smaller ships, catamarans, ships that hover above the water. But these are ships that are good for scouting or ships that are good for inserting small numbers of special forces. They are not really how you're going to transport large amounts of armor, fuel, and people. So in vehicles in general, I think progress is moderate. And I'm making this claim in relation to previous history and in relation to what would be required to achieve dramatic breakthroughs on the battlefield of tomorrow. Now, it's true in computer technology, we're seeing a lot of radical improvements. And when you combine computer progress and digital progress and artificial intelligence and other such breakthroughs with some of the more modest progress in vehicles, we may see a net effect that is still borderline revolutionary with things like swarms of projectiles or swarms of defensive interceptors. And so I'm not trying to dismiss the possibility of big change, but it's going to be specific to certain areas where we can really achieve these sorts of effects. And so, for example, what I am hopeful for is that over the next 10 years, we will figure out together how we can build defensive swarms of interceptors that could be essentially dispersed into the air around Seoul and cover a large fraction of the Seoul metropolitan area to be able to defend against incoming North Korean artillery or rockets. And then to be a network, essentially a mesh that is a self-repairing mesh using artificial intelligence and sensor technology such that this unmanned system, with thousands of projectiles, maybe tens of thousands, that is able to stay up in the air for hours or even days. Maybe you have to bring it back and, charge up the batteries or refuel the engines, but hovercraft essentially of one type or another that have the ability to then move quickly into position to achieve a hit-to-kill intercept against an incoming artillery round or rocket. I'm hopeful that we can see those kinds of technologies come to fruition in the next decade. And so that maybe we could begin to see how to protect the Seoul metropolitan region from various kinds of North Korean threats that we have not been able to defend against as an alliance for a long time. So again, I'm not here as a Luddite to tell you that no technology is going to come online that will be important or that change will always be slow. There could be some areas of very specific progress, but I just think we're going to have to identify them one by one rather than use our arms in a sweeping way to say that we're at such a radical period of change in general that all technologies are going to be fundamentally altered. That's just not true. It is true in some areas of cyber and digital progress. It's not generally true in sensors. It's not generally true in vehicles. So let me now, with the 7 minutes or so that I have left, turn to the Ukrainian battlefield and look at lessons learned there and maybe try to take these general ideas that I've been trying to frame and make them more specific. So when I look at the Ukrainian battlefield, and I'm sure you're studying it too, and I'm glad to say that I know the Department of Defense in the United States is studying it quite carefully. I've been in conversations along those lines at the Pentagon. Some of the very best young officers in our military are studying the Ukraine war, not just to help Ukraine, but to help ourselves with new ideas on innovation and modernization. And at one level, the Ukrainian battlefield looks very similar to the World War I Central or Western Front in the years 1915, 16, 17. Very slow moving. Defense seems to have the advantage. When people dig in, they are relatively safe. Fortifications are very difficult to traverse. Multiple lines of trenches with pre-calibrated artillery fire for any approaching troops, as well as other kinds of explosives and barbed wire. These kinds of technologies are in many ways dominant, just like they were more than 100 years ago in Europe. It's stunning. On the other hand, we also see at least 3 or 4 new categories of technologies that are altering the details of how the war is fought, even if they are not altering the fundamentals. And I would put drones, cell phones, and small satellites, and the internet on that list. And of course, what we've seen with drone technology, and it's been remarkable just how widespread it's become, is that everybody's looking all over the place all the time at each other's systems. And this was, to some extent true in World War I, but people had to use their eyes. Now we've got the ability to send a drone, a first-person view drone out 10 or 20 or 30 miles sometimes, but certainly at least a few miles, and see if any enemy attack is being attempted and try to stymie any such attack before it even gets going. So in that sense, drones have made the defense maybe even more dominant today than it was on the Western Front in World War I. Although obviously drones can help with offense too, but unless you are able to really create a big effect in one sector, drones seem to, at first approximation, help the defense most. Then there are cell phones, which mean that now a citizen army, individuals who are not even in uniform, can call in positions on any Russian troops they see. This is part of how Ukraine saved Kyiv in 2022. Its own citizens were calling in information or using apps to give information about Russian troops they saw approaching the capital. And so this has now proliferated sensors to the point where it's not just the military's own dedicated sensors, but essentially everybody's cell phone, everybody's own eyes and ears become part of the C5 ISR network for the country. So that's new, although it may not be as relevant near the front lines as it was in the early days of the war around Kyiv and other big cities, because in those early days, the Ukrainian military was not as well set up, the front lines were not as well established, and therefore having all the citizen eyes and ears and cell phones to help was crucial. And then finally, the combination of satellites and the internet have allowed for information to be shared much more quickly. But of course, that was true in World War I with radios and with, cable that could be laid to allow people to communicate. And so once you have a static position like the trenches of World War I or of today's Ukraine or of the DMZ in Korea, then you have multiple ways of communicating. And yes, small satellites are nice. Yes, internet hubs out in the dispersed forces are nice to have. But again, I'm not sure it's a radical change from where we've been historically. Okay, so I've only got a minute or two left. And the way to conclude, I think, is clearly to ask, what does all this mean for the US-ROK alliance and for the Korean Peninsula? I don't see any technologies that are going to change our basic vulnerability to nuclear weapons or chemical weapons. I do hope we can potentially start to counter artillery and rockets with swarms of defensive interceptors. I do think that maneuver is still possible, but we're going to have to try to concentrate jammers and spoofing devices and other ways of distracting and disorienting any kind of a North Korean defensive position if we're going to try to drive through it. We can't do what the Ukrainians did last year, which was to try to have a fairly well telegraphed assault across multiple sectors at sort of a moderate intensity. That's not going to work in today's technological. The North Koreans have enough capability to stop that. But if we use maneuver, jamming, modern technologies, three-dimensional assault, including with the air and through the sea and around defensive positions, I still think we would have a good chance, to be able to penetrate North Korean lines. And thank God we have two of the world's 5 best militaries working together on this job between the United States and the Republic of Korea. And that's why I say, again, it's been a great honor to be with you today. I wish you a great conference. Look forward to seeing some of you in Washington or Seoul in the near future. And thank you again for this privilege.